Hello, everyone. Mr. Minnick's my name. Math is my game. This morning, what we're going to take a look at is Chapter 4, Section 1, the introduction to Chapter 4, the biggest chapter in all of Algebra 2. The one that everybody who's taken Algebra 2 says, oh, that Chapter 4 test. Because there's actually going to be 4 Chapter 4 tests. When we get halfway through the chapter, there's going to be one on the calculator part and not the calculator part, and then when we get all the way through, there's going to be another 2 more tests. So anyway, Chapter 4, Section 1, the title is Vertex Form of a Quadratic Function. Vertex form of a quadratic function. Vertex form of a quadratic function. Chapter 4, Section 1, vertex form of a quadratic function. So I think to kick this off, what I'm going to do is take another look at the parent quadratic function. We talked about families of functions in Chapter 2, Section 6, I believe. So if we look at the parent quadratic, the mommy and or daddy quadratic, anybody remember what its equation is? Wasn't it y equals x squared? Remember that? So if we came up with a table of values, x, and rather than writing y in my table, watch what I'm going to write. Rather than writing y, I'm going to write, in about 3 seconds, 2, 1. I'm going to write x squared because that's where my y's are coming from. Hopefully you're picking up what I'm putting down there, and that makes sense why I'm doing that, no pun intended. So if I have 0 and I square 0, of course it's going to be 0. And if I have 1 and I square it, it's going to be 1. And if I have negative 1 and square it, this is where the magic starts to happen. When we square negative 1, what do we get? 1. Good. And when we square 2, we get 4. And when we square negative 2, we also get 4. And then we get 3, 9, and negative 3, 9. Now these points are all the ones that are going to show up on our 10 by 10s that we traditionally use. So you should be familiar with this function. You should have seen it before. You should be able to graph it with your blindfolded with one arm tied behind your back. You should be able to tell me what the vertex is. You should be able to tell me what the domain is and what the range is. And if we look at this function when we plot these points, on Wednesday's quiz, I will ask you to label the vertex. Merely drawing a dot like that does not constitute labeling a vertex. Let me be real clear about that. On Wednesday's quiz, I will ask you to label the vertex, and merely drawing a dot like that does not constitute labeling the vertex. I'll say that a third time. On Wednesday's quiz, you will be graphing this same function, and merely plotting that dot does not constitute labeling the vertex. Labeling the vertex means you have that dot, you put a V, and you say, well, the coordinates there are 00, or the origin. You picking up what I'm putting down? Good. So labeling at least 5 other points, that's not labeling, that's just plotting it. Plotting and labeling mean 2 different things. Plotting it means drawing the dot. Labeling it means, okay, this is point P with coordinates 1, 1. Labeling it, do you need to put the P and the Q and the R? Not really, but so this other point is negative 1, 1. And then we've got the 2, 4, the 2, 4. So when I say label, to be crystal clear, what I mean when I say label is I mean you'd better not only plot the point, but put its coordinates as well as an ordered pair. So you will be asked to sketch this graph just like that on Friday. I keep saying Friday, on Wednesday's quiz. Okay? Keep in mind that this is curved. And then there's this vertical line that goes through it. I don't need to make it dotted. Maybe I won't. I'll go ahead and make it solid. There's this vertical line that goes through it, and it's called the axis of symmetry. The axis of symmetry, and its equation is x equals 0. On Wednesday's quiz, I will ask you to write the defining line for the axis of symmetry, and you'll say the axis of symmetry's equation is x equals 0. Domain and range, I'm not going to ask about those, but just in case you wanted to Refresher on that. The domain goes from negative infinity to infinity. In the range of this particular function, this is where things start to get a little bit different. I think we may have talked about this last week, but the range of this, anybody got it? Yeah. Bracket 0, good. Bracket 0, and then what? Comma infinity. Excellent. Nice job. Good. Brought our A game. You mind if I shout you out? Ms. Konachek, Alex Konachek, brought her A game today. Shout out to her. Nice job. So how's everybody feel about this parent function, okay? Now there are a couple things about this parent function that I need to point out. The parent function looks the way it does because the parent function is really y equals 1 times the quantity x minus 0, the quantity squared plus 0. Oh, is this like that implicit things that you talked about the other week ago, Mr. Minnick? Yes, it is. Yes, it is. So let's see what the heck all this means. The vertex of this thing, because of this 0 being subtracted from x in here, that's the x-coordinate of the vertex. Because of whatever's being added to this function at the end after the parentheses, because of that, the y-coordinate of this function is 0. And because of this 1 right here, and because of that 1 right there, this function is as steep as it is. This function is as steep as it is. From the vertex, I'm going to go over 1 unit. I'm going to go over 1 unit. And you know how high up I'm going to go? I'm going to go 1 unit up when I go over 1. I'm going to go 1 unit up when I go over 1 because of that 1. So far, so good. Cool. So I could talk for literally a month about A. So what's the deal? So what's the deal with A? Question mark. And what I'm referring to is graphing something of the form y equals ax squared. Because we really need to explore that, not for a month, but at least for the next 5 to 7 minutes. We really need to get a good idea of what A is. Why? Well, because the state content standards say you will. Why? Because Wednesday's quiz has an essay question about A. And because A is A, and we're going to study 3 other forms of this function, and if you don't understand what A is now, you won't get it then. So let's take a good look at A. So on my TI Inspire, what I've got going on here is I've just got a graph page. I'm going to go ahead and zoom in. And I would like to view my grid. So if it cooperates, I'm going to go ahead and view my grid, an aligned grid. And I'm going to graph the parent function, y equals x squared. So one thing that I'd like you to notice, I don't know if my smart ink is going to show up, but there it is. So we've got the origin. And when we went over 1 unit, we went up exactly 1. And the reason we did is because of our A value being 1. So far, so good. Now, what do you think is going to happen if my A value is 2? When I go over 1, how far up do you think I'm going to go? 2. Let's see if that's true. So if I go ahead and plot another function here, if the calculator lets me, I'm going to try to plot another function. I'm going to plot 2x squared. So now let's see what happens. When I go over 1 unit, I should have gone up 2, and I did. So let's see what happens if my A value is something like, negative 1/2. Negative 1/2. Negative 1/2 x squared. So now, this time, when I go over 1, how far down should I have gone? How far down should I have gone? 1/2. And if we look at the graph, I did. So far, does this make sense? Cool. So on Wednesday's quiz, you're going to have to graph a a function that's not the parent function. It might be a stretch, it might be a compression, but the deal is all graphs of these functions relative to the vertex are going to go through the point 1 comma a. Okay, every single graph relative to the vertex is going to go through the point 1 comma a. So in other words, if you go over 1 unit from the vertex, you're always going to either go up a if it's positive or down a if it's negative. So if we look at this graph, we see the x squared, 2x squared, those graphs open upward. The negative 1/2 x squared opens downward. So what can we say about a, whether it's positive or negative? What happens? So let's say this. If a is positive, what's that mean the graph's going to look like? The graph will open up, right? The graph will open up and have there's an M word I'm looking for. There's an M word that ends with mum. There's an M word that ends with mum. Lots of M's in this word. 3 M's, in fact. If the graph opens upward, the vertex, more specifically, the y coordinate of the vertex is called whatever this thing is. Yes. Thank you. A minimum. A minimum. A tiny mother. A minimum. A minimum. That was a bad joke. Sorry. It's too early. So does that mean if a is negative, then it's going to have the biggest mother? Yes. A maximum. The biggest mother. So if a is negative, maybe I'll use a different color here. If a is negative, the graph will open down and have a maximum. Okay. So there's something else that people try to say about a, and they make a mistake when they say it. I'm going to say that a really isn't slope. Some people, when they do the essay question on Wednesday's quiz, they want to say that the a is a slope. It's kind of slope, but the deal is with quadratics, the slope isn't the same. And I'll show you that using the TI Inspire. So the slope of a quadratic isn't constant like a line is. And we'll take a look at that right now, because this is kind of some calculus level stuff, so if it goes over your head, don't sweat it. But for those of you who that are kind of picking up what I'm putting down, it might answer some of your questions. Let me just clear this ink off of here real quick. One more layer of ink. There we go. Okay. So if I look at something like 3x, which is just a line, and I wanted to see its slope, I could actually use my special eyes and I could use some calculus. And one thing I notice about the slope, I don't know if you could see the number 3 in the first quadrant. Do you see that? The slope is 3. Now it's asking what position is the slope 3 at? Well, it's 3 everywhere you go along the line. The slope is 3 whether you're down here, whether you're up here. You with me so far? Now if I look at a quadratic, this time, 3x squared, let's say, and I want to know its slope, I want you to see what's going to happen here with its slope. I'm going to use my special eyes and I'm going to use some calculus. And its slope right here is about 2.5, and its slope right here is about 6 3/8. Its slope up here is 7 something, and its slope on the other side of the x-axis is negative something. So the deal is we really can't use the word slope because it's not constant. Does that make sense? Okay. But a does tell us how how tall the graph is or how wide the graph is. Okay, so we can say that A will tell us how wide or narrow, the graph appears. The graph appears. A will tell us how wide or how narrow the graph appears. Will tell us how wide or narrow the graph appears. So if we go back to this and we change that 3x squared to a 0.03x squared, which one looks wider, 3x squared or 0.03x squared? 0.03x squared, right? Now, which number is bigger, 3 or 0.03? 3, obviously. So what's the deal? As A gets bigger, what do we say? The graph appears to be narrower, or it is taller. Does that make sense? Everybody understand what the purpose A serves? Cool. So in tonight's exercises, you might have to graph something like this. So here's example 1. Graph y equals 5x squared. The nice thing about this is on graph paper, there's only going to be 3 points that are going to fit on the graph paper, so there's not much work to do. And if you understand what A does, you'll be able to graph these that fast without touching any kind of graphing technology. So I want you to realize that this is really y equals 5 times x minus 0, the quantity squared, plus 0. So when we talk about the vertex of this thing, what's the coordinates of the vertex? Somebody said it. 0, 0. So the vertex for this graph is going to be located at the origin. Plot, label the vertex. Origin. Bam, there it is. Now, if we look at our A value says, okay, from the vertex, we're always going to go over 1. And I don't know why people have such a hard time with this, but we're always going to go over 1. And then the A value is going to tell us how far up or down to go. So we're going to go up 5. Yeah, that's it. That's it. So over 1 and up 5 because of our A value equaling 1. Since A equals 1, we go over 1 and up 5. And that's it. It's that easy. I feel like an infomercial when I say this, but there's not more. That's it. That's it. It's that easy on this one. So remember, this is curved. This is curved. This is parabolic in nature. We should put the arrowheads on it, but that's all there is to it. Do we feel okay about graphing something like that? Okay. So where things get a little bit dicey is this next one. Example 2. Graph y equals 1/4 x squared. Ooh, fractions. We sometimes despise them. I'm going to start up a table of values, x and x squared for the parent function, and then 1/4 x squared. So I know my parent function goes through the origin. I know my parent function goes through 1, 1, and 2, 4, and even 3, 9, and even 4, 16. So what is different about this? What's different about this is all my y values are going to get multiplied or compressed by a factor of 1/4. What's 1/4 of 0? Still 0. What's 1/4 of 1? 1/4. What's 1/4 of 4? 1. Good. Now let's skip over the 3, 9 for a minute. What's 1/4 of 16? 4. Good. Now 1/4 of 9 is 9/4, or 2 1/4. So if I had to graph this one, I could still certainly do that quite simply. It's not that bad. Once again, we could see that our vertex is the origin. And our A value does tell us, hey, we're always going to go over 1. We're always going to go over 1, and how far up are we going to go? 1/4, right? Since our a value is 1, we're going to go over 1 and up 1/4. Now that's kind of hard to represent on the graph. And now since we made this table, this is kind of cool. So when we go over 2, how far up are we going to go? When we go over 2, we're going up 1. So relative to the vertex, we go over 2 and up 1. When we go over 3, we're going up 2 1/4. And finally, when we go over 4, we're going up 4. Over 4 and up 4. Okay. So that is how you could go about graphing one of those without touching a graphing calculator. I think it's much easier to do that than it is to punch in y equals 1/4 x squared on a TI Inspire. Any questions about that one? Comments? Concerns? Well, I think we're ready then to see vertex form. Here it is. Vertex form. Vertex form. Let A, H, and K be any real number, with A not equal to 0. Vertex form is as follows. Vertex form is y, or f of x, equals a times the group x minus h, the quantity squared, plus k, with vertex h comma k. With vertex h comma k. I'll leave that up there a minute. When we get through the second section, I'm going to ask you, what's vertex form? What's standard form? List any restrictions. And what I'm talking about when I mention restrictions is that part that says let A, H, and K be any real number. That's part of the restriction. Let A not equal 0, that's also part of the restriction. So that's vertex form. A times the quantity x minus h, the quantity squared, plus k. And of course there's a y or an f of x equals, but that's it. That's vertex form right there. That's what it looks like. Oh my smartboard. Trying to get that dot out of there. There we go. I think that might have been I don't know what that was, circle. Okay. One thing to notice about the vertex, look at the vertex's coordinates, hk. Don't you think it should be negative hk? Remember when we talked about families of functions and how the horizontal translations were the opposite of what you expect? Is it starting to make a little bit of sense now why? Okay. So to be real clear, on Wednesday's quiz, I'm going to ask you to discuss the variables a, h, and k. So to be as clear as I can be, h is the x-coordinate of the vertex. H is the x-coordinate of the vertex. And h is kind of related to the axis of symmetry because the axis of symmetry will always be x equals h. The equation of the axis of symmetry is always going to be x equals h. K is the y coordinate of the vertex. Now, we talked about functions sometimes opening up and functions sometimes opening down. So if the function opens up, then k is the, is that the big mother or the small mother? The small one. K is the tiny mother, the minimum value. The maximum or minimum occurs at the vertex, but to be clear, the y coordinate of the vertex is the minimum value. Conversely, if A is negative, if the graph opens down, then K is the maximum value. A, H, and K have to be real numbers. Could they be pi? Yeah, pi's a real number. Could they be the square root of 9? Sure, they could be. Any real number, as long as A doesn't equal 0. Could anyone discuss or tell me what would happen if A actually equaled 0 and you're trying to graph a quadratic function in that form? It's a horizontal line, and is a horizontal line a quadratic function? No, that's why there's that restriction of A. Nice observation, good. We ready to see this in action? All right, so I think we're on example 3, right? Example 3, without graphing, identify the vertex, the axis of symmetry, and the min or max value. And we'll do a couple of these. Example 3a, 3b, 3c. So we'll go y equals x plus 1, the quantity squared. We'll go y equals 13/19 times the group x minus 17, the quantity squared, minus 18. And we'll go y equals 3 minus 2/5 times x plus 4, the quantity squared. That ought to do it. So I'd like us to try to identify the vertex, the axis of symmetry, and the minimum or maximum value for each. So I guess to be consistent with this, when we talk about the vertex, I'll go ahead and put that in green pen here, the vertex. Anybody think they got number A, the vertex? What do we got? -1, 0. Nice, good job. So the deal is with number A, let me see if we can do this. Number A, this is really x minus 1, the quantity squared, plus 0. So the coordinates here are actually -1, 0. The x-coordinate of the vertex is counterintuitive. It's the opposite of what you would think it is. If it's a +1 in the parentheses, then it's a -1. And the y-coordinate of the vertex is just whatever's added. How do we feel about this? Good so far? Let's go to number B and see if we can figure out number B's vertex. Anybody got number B's vertex here? Yeah, what do we got? 17, -18. Awesome, good, sweet, rad. And part C here, the vertex, be careful on this because this is in quasi-vertex form. It's not quite in vertex form, so it's a little tricky. What are we thinking? -4, 3 is correct. Good, -4, 3. So if something's in quasi-vertex form and you wanted to be clear about it, you could go ahead and put it in vertex form. This is -2/5 times the group x minus -4, the quantity squared, plus 3. So yeah, number C is -4, 3 is the coordinates of the vertex. Okay, cool. How do we feel about being able to do that, okay? All right. The directions should have said without graphing. I forgot to make it a gerund without graphing. Okay, so the axis of symmetry. We'll do this in purple. Example 3a, the axis of symmetry. Anybody got it? Yeah. Not -1. If you said -1 in Mr. Englehart's class, you'd get elbowed in the face. Not really. I'm just teasing. It's not -1/2. I heard an x equals. Yeah, the axis of symmetry is an equation, and it's got to be x equals, so it's x equals -1. X equals -1. So how about number B then? I know B's not a number, but number B, yes. X equals 17, and finally C, what do we got? Yeah. X equals -4, good. So the axis of symmetry is always going to be x equals h. What's h? The x coordinate of the vertex. So far, so good. Cool beans. So now we're talking about this minimum or maximum value. So when we talk about this minimum or maximum value, we need to specify whether it's a min or a max. And then that value we said was simply the y coordinate of the vertex. So number A, because our A value is positive, the graph opens up, and that one would have a minimum, right? So to kick this off, our minimum value would be the y coordinate of the vertex, so it's 0. So how about number B then? Would that have a minimum or a maximum value? I'm hearing minimum, I'm hearing maximum. What would it have? It would have a minimum because our A value is 13/9, but that's still positive, right? So the graph opens up. So this would have a minimum value. Would have a minimum value, and what is the minimum value there? -18, just the y coordinate of the vertex. Okay. The last one here. Our A value. What is our A value in this one? -2/5, which means this graph is going to open down. So what's this going to have? This is going to have a maximum value. This is going to have a max value, and the max value of this thing would be, somebody said it, 3. What do we think? Make sense so far? Good. All right. Well, I think we're on example 4, right? Example 4. Try. No, we'll graph. We'll try to graph. Graph y equals 1/2 times the group x minus 3, the quantity squared, minus 7. Does anybody in here know who Kazoo Kid is? I love Kazoo Kid. I like to have fun. I like to pretend. What I'm getting at is at some point in the graph of this particular function, I'm going to pretend that the -3 and the -7 aren't even there. So what I'm getting at is I'm going to pretend like I'm graphing y equals 1/2 x squared. I know how to do that because we just did that at the beginning of the lesson, right? Wherever its vertex is, I go over 1 and up how far? Over 1 and up how far? Up 1/2, right? Now, if I were to go over 2, how far up would I go? 2. If I were to go over 2, I would go up 2. So I know what this function looks like. Thinking back to last week in our families of functions, and thinking back to this lesson, the only difference is our vertex is located in a different location, isn't it? What are the coordinates of the vertex of this one? The vertex here is 3, -7. So rather than starting where I did, I'm going to start at 3, -7. I'm going to start at 3, -7. So rather than starting up here, I'll be starting to graph this thing down here. And what I just did up around the origin, I'm going to do the same thing. This method of graphing is so powerful because you can use it anytime on any function as long as you know what the parent function looks like. You don't need to make a table of values relative to this mess. So from our vertex was right there. We went over 1 and up 1/2, and over 2 and up 2, and that's it. That's it. It's that easy to graph these things. What do you think? Make sense? Cool. Cool beans. Do we need to try one more, or is that enough? I'm hearing some people say that's enough. Got him? All right, well, that's all I got. It's been real. It's been fun. I hope everybody has the best day of their lives. Happy homecoming week. See you next time.
Good.